Welcome to statics lecture number 2. In my last lecture, we looked at finding resultants of two concurrent forces. So we had two concurrent forces and we found the resultant of that. In this example number 1, we have four forces to look at. So 1, 2, 3, 4. I've already drawn the free body diagram, and we're supposed to find its resultant. So four forces, find its resultant. As you can see, I have taken all these forces here, these four forces, and made them into their separate force systems. So we have four force systems here. The first thing we're going to do is find the components of each of these force systems. So this is the first one with 15 newtons. Let's just write 15 newtons here. It's 50 degrees from here. Whenever we're finding the components, we should always take it, or we must take it from the x-axis, not the y. This one gives us 50 degrees from the y, so from the x it would be 40 degrees. So for this one, we would have the x component would be 15 cos 40 degrees, and the y component would be 15 sine 40 degrees, which equals 11.5. For y, it equals 9.6 newtons. Let's take a look at the second one. The second one's 25 degrees. 25 newtons. So it's 25 newtons, and it is 25 degrees from the x-axis. Therefore, x is equal to 25 cos 25, which is equal to 22.7, and y is equal to 25 sine 25, which equals 10.6. The third one is the 10 newtons that I have here, and it is 45 degrees from the x-axis. 45 degrees from the x-axis. So therefore, x is equal to 10 cos 45 degrees, which equals 22.7. Y is equal to, not 22.7 actually. It equals 7.07. Y is equal to 10 sine 45, which also equals 7.07. Now, when we're finding components, we're finding the y value and the x value. For the x value, this is whenever it's going to the right, it's a positive number. If it's going down or it's going to the left, it's going to be negative. So therefore, the y would be negative 7.07. So then we have this force, which is this last one over here, 20 newtons. So 20 newtons. And it's 15 degrees from the y-axis. But we always take it from the x-axis. So then this would be 75 degrees. X is equal to 20 cos 75 degrees, which equals 5.2. And remember, this is actually going this way, this component, the x component, so it's going into the negative direction. So therefore, this has to be negative 5.2. Y equals 20 sine 75 degrees, which equals 19.3. Again, the component of the y is actually going down, so this has to be negative as well. So let's add up all the sum of the x forces and sum of the y forces, and that will give us the component of our resultant. So let's add up all the x forces. So we have, first of all, we have 11.5 from here, plus 22.7, plus 7.07, minus, remember this is the only x force or x component that I should say that's going to the negative direction. So it's going to be minus 5.2. That equals 36.07 newtons. Let's do all the y forces. 9.6 plus 10.6 minus, remember this one's going down, so it's going to be minus 7.07, and this one's also going down, so it's going to be minus 19.3, which gives me 0.17 newtons. So these are the components of our resultant, the x component and the y component. So if I go down here, I've already drawn it for you. So the y component is going to be down, and this is going to be in the positive direction, so this way. So essentially this is 36.07 and the y is minus 6.17. So we know the resultant of these forces is somewhere is going to be somewhere like this. We don't know the direction, we don't know the degrees or the magnitude of it. So one of the ways we can do that is if we kind of do this. This is a 90-degree angle, and we have to find this side. So it's like finding the hypotenuse, right? 36 and 6.17 should give me the hypotenuse here. So we're going to use Pythagorean theorem, and I'm going to call this resultant. So r square equals 36.07 square plus 6.2 square. The reason I put plus there is because if I put negative, it's gonna give me a positive answer anyways. So it doesn't really make a difference. Which equals, and if you work all this out, it's gonna equal 36.6. So that gives me the magnitude of this, which is 36.6. Now I have to find the direction as well, so I need to find theta. That's where we're going to use SOHCAHTOA. So remember SOHCAHTOA from my previous video. So we have the opposite and we have the adjacent. So we know what this side is. Well, this is 6.17, and we know what the adjacent is, which is 36.07. We also know what the resultant is as well, but we're just going to use the ones that were given for now. So we're going to use tan, which is opposite over adjacent. So therefore, tan theta 1 equals to opposite over adjacent, which equals to opposite is, and you can put negative 6.2 or you can put 6.2, but we're going to put negative 6.2, 36.1 to the tan negative 1, which equals negative 9.7 degrees. So this is 9.7 degrees. And even if I didn't put negative there, I still would have got positive 9.7 degrees, and it would have been 9.7 degrees here. And we know that our resultant is going to be in the fourth quadrant because we know the components are going down this way, and it has to be in the middle. So therefore, our final answer is resultant is equal to 36.6 newtons at 9.7 degrees. Oops, and the direction would be that way.